Now we talk about the transport and sinks of tropospheric aerosols. Before that, we talked about the transport and sinks of tropospheric gases. Now, the tropospheric aerosols are transported through the atmosphere by the airflows they encounter. That means they are in the atmosphere, and then they are subjected to airflows when they are in the atmosphere, and these move this aerosol into many parts of the globe due to the movement of the airflow, and the scales that they are on are on the intercontinental and global scale. That means they move very far distances from the position where they are created or they are emitted. And there are also sinks of tropospheric aerosols. On average, the particles are removed from the atmosphere at about the same rate as they enter it. That means as they go into the atmosphere, they are also removed from the atmosphere at the same rate, which means that they don't accumulate in the atmosphere. And improvements in visibility, there's a reduction of visibility when there are increased concentration of tropospheric aerosols. When there's an improvement of the visibility, it comes from atmospheric processes such as precipitation that are able to remove the tropospheric aerosols through the process called scavenging. Rain collect aerosol particles, specifically the ones that are more than 2 micrometer in diameter, because of the process impaction. But for particles that is about less than 2 micrometers, but more than 1 micrometer, gravitational settling is important, because rain is not able to impact appreciably those smaller size particles, which makes it more important for it to settle down to be removed from the atmosphere than to be removed through scavenging or precipitation. There are 3 main particle groups in terms of that are categorized based on their particle diameter. One is for d less than 0.01 micrometer on average, which is categorized as ultrafine particles. And then there's the second group, which is between 0.01 micrometer up to 2.5 micrometer, and these are called fine particles. And there are also particles that are more than 2.5 micrometers, and these are what we call the coarse particles. Residence time is a very important parameter of these particles. Usually the lighter the particle, the longer the residence time. So if the particles is less than 0.01 micrometer, then the residence times, how long it lasts in the atmosphere, is about 1 day. And the way that it's removed from the atmosphere is through diffusion to cloud particles or coagulation. And for particles that are more than 20 micrometers, it is still about 1 day. And the way that it's removed from the atmosphere is through sedimentation. That means settling, impaction through precipitation, or through impact on other particles in the atmosphere that's able to remove it from the atmosphere, as well as precipitation scavenging. Now, the particles between 0.2 up to 2 micrometers, the residence times is much longer, by order of magnitude of 2 times. They can last hundreds of days in the upper troposphere and only tens of days in the lower or middle troposphere, because of the turbulence or the vigorous mixing in the lower part of the atmosphere. And these are the particles that tend to accumulate in the atmosphere and increase its concentration.